28th lesson is Pre-Algebra Unit 3, Lesson 12, One-Step Inequalities, Multiplying and Dividing. Here's the homework that goes along with it. Okay, I want you to pause and do these problems. All right, as a review, when you are adding or subtracting decimals, you need to line the decimal point up. So this would be 17.0 plus 2.3 is 19.3. I would think a lot of you could do that mental math because $17 plus $2.30 is $19.30. Okay, when you are subtracting, line the decimal up. We need to add some zeros because we need to borrow. We can't borrow from the zeros, so that becomes a 1. 10 becomes a 9, 10. So we have 4, 1, 0, 5. All right, remember when we are multiplying decimals, forget about the decimal point. So this is 12 times 3 is 36. And then count the number of decimal places after the decimals. 1, 2, 3. So 1, 2, 3. Now, dividing. The first number always goes inside the division box. The number up front cannot be a decimal, so we need to move the decimal over 1, move it over 1 here, and bring it straight up. 2 goes into 4 2 times. Make sure you line things up nice and neat. Bring down the 3. 2 goes into 3 once. That's 2. Subtract, you get 1. Bring down the 2. 2 goes into 12 6 times. So 21 6 tenths, and it is a terminating decimal. All right. Pause the video and do this one. All right. 12, the quantity 12 plus 8 plus 5 equals. Which one would the right side look like to illustrate the associative property? Well, the associative property, the grouping changes. So the order would be the same. 12, 8, 5. But the grouping would change. So that is C. Do this one. Pause your video. Okay, we're looking for which one would illustrate the commutative property. There may be more than one answer. So, commutative property is the order changes. So, we have 12, 8, 5. So let's look down here. 8, 12, 5? Yeah, the order changed. 12, 8, 5, same order. 5, 12, 8, order's different. 12, 8, 5, so it's A and C. Any one that shows order changing is commutative. Pause your video and do this one. All right, which one would illustrate the distributive property? There may be more than one answer. Well, if I distribute, 5 times x is 5x, positive 5 times positive 6 is positive 30. So that's one of them. Well, isn't this the same thing, 5 times x plus 5 times 6? So B. This one is order, so that's commutative, and this is not. All right. We talked about adding and subtracting inequalities yesterday. Today we are going to do multiplying and dividing. Before we do multiplying and dividing, I want to show you something. You probably want to write this down on a separate piece of paper. So, yesterday, I'm making up an inequality. If 2 is less than 4, that's always true. I can add 2 to both sides, and I'll have 4 is less than 6. Still true. We know we can add a number to both sides, and it doesn't change its value. Let's do subtracting. I'll have 0 is less than 2. Still true. Adding and subtracting we did yesterday, just like inequality, or equations. Now, today we're going to do multiplying and dividing. So let's start with the true inequality. Let's multiply both sides by 2. If I multiply by 2, I get 4 is less than 8. Still true. So, multiplying by a positive works. Let's do dividing by a positive. Divide both sides by 2. I get 1 is less than 2. Still works. Dividing by a positive works. Now, this is where things get tricky. Look, 2 is less than 4. If I multiply both sides by a negative 2, I will have negative 4 on this side and negative 8 on this side. Negative 4 is greater than negative 8. Think about where they are on the number line. So, let's do dividing by a divide both sides by -2. And I get -1 and -2. -1 is greater than -2. This is a key point. When multiplying or dividing both sides by a negative, you must switch the inequality. Now, pause this and write that in that box. We're on page 16 in your notes. So, the key is when you multiply or divide both sides by a negative, you need to switch the inequality. Solving equations, or solving inequalities, is just like solving equations, except that point. When you multiply or divide by a negative, you need to switch it. All right, now, let's look at some examples. We are on page number 18 in your notes. All right, let's solve. So in this one, I divide both sides by 4. So I have x is, I've divided by a positive 4, so I do not switch the inequality. X is less than -4. Even though my answer is negative, I divided both sides by a positive, so I don't switch it. So let's draw our graph. We're going to have an open circle, less than is to the left, because x is less than -4. This one, divide both sides by -80. So I'm going to have p is. Now, we divided by a negative, so we need to switch our inequality. P is less than -10. Open circle, shaded left. Graph, don't forget to switch if you multiply or divide by a negative. Example 3, I would multiply both sides by 4, because this is t divided by 4, and I'll have t is greater than 8. I don't switch my inequality, because it is multiplying by a positive. This one, I need to multiply both sides by -2. So I'll have x is, you need to switch your inequality, greater than -2. So here's my graph, open circle, shaded right. Remember, if you multiply or divide both sides by a negative, you need to switch the inequality. Everything else is the same as solving equations.